All right, in this section, we are working on writing equations of parallel and perpendicular lines. So what we want to do is we want to be able to identify if two lines are parallel or perpendicular using your slopes. We worked on this in the investigation in section D. And we also want to, if we're given the slope of a line, be able to find the slope of a different line that would be parallel or would be perpendicular. And then once we're able to do that, we want to be able to write the equation of a line that is parallel or perpendicular to a given line. So this will involve using some of the skills that we developed on writing equations of lines earlier in the learning guide. So just a quick look at a reminder on parallel or perpendicular slopes. So we're asked here to state whether each pair of lines is parallel, perpendicular, or neither. And we want to do this based on the slopes of the line. So if we look at this pair of lines here in section A, our first line here has a slope of 1/3. Our second line here has a slope of 1/3. Those two slopes are the same, so our lines are parallel because parallel lines have the same slope. If we look, if we actually jump down here to C, I've got my two equations here. The slope of my first one is 5/4. The slope of my second one is -4/5. We notice that these two are negative reciprocals. We've interchanged the numerator and the denominator, and we've changed the sign from positive to negative as we go from one to the other. So these two are going to be perpendicular. Okay, coming back to B here, our slopes in B, we've got a slope of 3/5 and a slope of 4/5. Those two slopes are not the same, or neither are they negative reciprocals. One isn't like a flipped over negative version of the other one. So these are neither parallel nor perpendicular. If we come down to D here, it's obvious in D here that if we're looking for the slopes of our two lines here, the slope of our first line is just going to be 2. We have to do a little work here to figure out what the slope of our second line is because it's not given to us in slope y-intercept form. It's given to us in standard form. So let's do the rearranging here to get y all by itself. So I'm going to keep the 4y exactly where it is, and I'm going to subtract 2x from both sides, and then I'm going to add 3 to both sides. And then to get this into slope y-intercept form, I have to divide everything here by 4. So this would be -2/4x plus 3/4. So now I can say that the slope of this line here is -2/4 or -1/2. Now I can compare my slope of 2 to my slope of -1/2. Okay, 2 is like 2/1. If I take that 2/1, I flip it, make it the reciprocal, I get 1/2. And if I make it negative, I'll get the negative over here. So these two are perpendicular. Our next pair here, both of these are not in slope y-intercept form. So I'm going to do a little bit of rearranging here. I'll keep the -y where it is. I'll bring the x to the other side by subtracting x from both sides. And then I'm going to divide everything by -1. So my slope here is +1. For my second equation, again, I'm going to keep the y where it is. I'm going to bring the x to the other side by subtracting x on both sides. My slope here is -1. Okay. These two are, well, perpendicular because I can think of this as +1/1. I can think of this as -1/1. If I interchange the numerators, well, I'm just replacing 1 with 1, and I'm changing the sign. So these two are perpendicular. Let's take a look at F here. My slope of my first line is going to be 4. The slope of the second one here, if I think of this as 1/4 x, my slope is 1/4. think of the 4 as 4 over 1. These two slopes are reciprocals. I've interchanged the numerator and the denominator to go from 4 over 1 to 1 over 4, but I haven't changed the sign. Both of these are positive, so these are neither. They're not perpendicular because of that. I haven't changed that sign, but they're not parallel because the slopes aren't the same either. And our last one here, G, x equals 5. If you remember from last year, an equation that has the form x equals is always a vertical line. And this equation that has the form y equals 7, just y equals something, is going to be a horizontal line. Horizontal lines and vertical lines are always perpendicular to each other. All right, let's look at how we can kind of use this to take this knowledge of parallel and perpendicular lines and apply it to solve some problems involving finding the equations of lines. Okay, so as I just said, we can combine our knowledge of parallel and perpendicular slopes with the algebra that we use to find equations of lines to solve problems. So our first example here, we are asked to determine the equation of the line perpendicular to y equals 2x plus 5 that passes through the point negative 2, 6. So in these questions, we always have like our old line here. And we have a new line that we are trying to create. And we want to take information from this old line and use it to figure out some stuff about the new line. So what are we told about our old line? Well, this is our old line, y equals 2x plus 5, okay? And our new line, we're told, is perpendicular to it. Okay. So what do we know about lines that are perpendicular? We know that the slopes is the negative reciprocal. So what is the slope of our old line? Well, the slope of this old line is 2, or if we think of it as a fraction, 2 over 1. We want to take that 2 over 1 and turn it into the negative reciprocal to get the slope of our new line. So we're going to interchange the 1 and the 2. So it'll become 1 over 2. And the slope of the old line is positive, so the slope of our new line is going to be negative. So our new slope is negative 1 over 2. So if we start trying to make the equation of our new line, we can start with, you know, our old y equals mx plus b, right? And we know that our slope is going to be negative 1 over 2, so we can sub that in for the slope. Now, our job here is we want to solve for this b value, because the two things that we need to write the equation of a line are the slope m and the y-intercept b. We've got our slope. We just need to find what our value for b is. Now, we go back up to the question here. They tell us that our line passes through the line, the point negative 2, 6. So if this is a point on the line, they're telling us that when x equals negative 2 on this line, y is equal to positive 6. We can use that down here in our equation. So x equals negative 2, y x equals negative 2, y equals 6. We're going to take those and we're going to sub them in here for y and x. So our y value is 6, negative 1/2. Our x value is negative 2 plus b. And now we've got a little equation that we want to solve for b. So start by simplifying by doing this multiplication in here. -1/2 times -2. Negative times negative is going to give us a positive. 1/2 times 2 is just going to be 1. So 1 plus b is equal to 6. And then if we subtract 1 from both sides, b is equal to 5. So we've got our y-intercept now. We just have to put it all together. Y equals our slope, -1/2, plus b, which is our y-intercept. And there's our equation. Y equals -1/2 x plus 5. Okay. All right. Our second example here. Determine the equation of the line parallel to 2x minus 3y plus 1 equals 0 and passing through the point 1, 2. So again, we've got our old line, which is 2x minus 3y plus 1 equals 0, and we want to use it to get some information about our new line that we're going to create. And what we're told about these two lines is that they are parallel to each other. So if they are parallel, they're going to have the same slope. So if we know what the slope is of our old line, we can use that as the slope for our new line. Now, what is the slope of our old line? Well, this is in standard form. So we need to put this into slope y-intercept form to figure out what that slope is. So let's start rearranging here. I'm going to subtract, I'm going to keep the -3y where it is, and I'm going to subtract 2x. I'm going to have to subtract 2x over here. I'll subtract 1 here. I have to subtract 1 over there. So this is going to be -3y equals -2x minus 1. Then I've got to get y all by itself, I've got to divide everything here by -3. Which is going to give me y equals -2 divided by -3 is going to give me a positive 2 over 3, x plus 1/3. So our slope of this line is 2/3. What does that tell us? Well, our new line has to have the same slope. So our new line is going to have a slope of 2/3. Here we go. Now we just need to find the y-intercept for this new line. So our new line, y equals mx plus b. We know that our slope is 2/3. So let's put that in. Now we need to solve for b. Well, to do that, again, we're going to look at this point that we're given here, which tells us an x and a y, and we're going to sub y equals 2 and x equals 1 into our equation. So y equals 2, 2/3, x is equal to 1, plus b. Do our multiplication first, so 2/3 times 1 is just 2/3. And we need to get b all by itself, so we're going to subtract 2/3 from both sides of our equation here. Now, if I'm going to do, like this just gives us b on the right-hand side. On the left-hand side, if I'm going to do 2 minus 2/3, I'm going to have to get a common denominator there. So I'm going to think of this 2 as 2 over 1. Okay. And my common denominator is going to be 3. I'm going to do 3 times the 1 to get the common denominator of 3. I have to do the same thing up in the numerator. So I'll get 6 over 3 minus 2 over 3 equals b. Looks like b is going to be 4 over 3. Let's put it all together then. Y equals, our slope was 2/3 x plus 4/3. And that's the equation of our new line.